So I also take the opportunity. My name is Ola Lindroos. I'm professor of forest operations, and I'm also involved in IUFRO or UFRO, depending on what kind of pronunciation you like. And this with office holders is a very good time now, because in the coming year there will be a change or a continuation, but it's a time to decide who should be the office holders in the coming years. So it's a very good time to kind of announce that I'm really interested. I would like to take part in leading or joining or something. So this is really the good time. And of course, the World Congress is excellent opportunity to see more of this. I will give you a presentation here, and it was first kind of prestigiously saying that I will give you the state of the art, but when we look at the program, we can see that you will present the state of the art, so I will not try to do that. I will instead try to give you some kind of context in terms of what are we trying to fulfill here? What are the higher objectives? What should all our endeavors meet? What should we ultimately try to achieve here? So that is what I'm trying to aim here for. And just to put this into context, what we're doing is rather simple things. In terms of logging, we want to transform standing trees to logs at industry, for instance. It's not rocket science, but it's challenging in many cases. And this goes for all of the things that we try to do. We try to do something fundamentally, and we try to find the best or most suitable way to do that. And how we do that is very variable. When you travel around the world, you often, at least for my part, when I came back, I thought that they are so stupid. Why do they do it like that? They could do it like us instead, and it's much better. But all these kind of different solutions, they are adaptation to local context, which are suitable or in some way a good way to do it in that context. And then there's, of course, possibilities for improvements, or when things changes, when the context changes, there's also possibility to change how you do things and improve that. And if we look upon the current trends in data gathering and data management, that enables improvement in two distinct different ways. First, we have to use the same kind of machines or technology in a better way. We can improve the things we do in different ways. And we can also, in some cases, or in maybe a little more further future, we can start thinking about redesigning the machines altogether, because this development have give us the opportunity to do it in different ways. So I will touch upon these things, most of the first and a little bit of the last of the redesigns in the end here. And if we look upon how we use the development currently, the new amounts of data enables us to improve planning and execution of the work. We start with having the possibility to collect data. And in the beginning, it's not so sure what we will or can use the data for. It's more like explorative. There have been many examples of researchers coming and saying, we can collect this data. We can follow the tree growth day by day. And in forest operations, go like, why? It doesn't happen very much from one day to another. And in some cases, it's like that. We don't maybe need it, or we don't know that we need it. And in some cases, it comes up, oh, if we know that, we can do this thing instead. So that is the thing that happens. And we will see many examples of this, both in terms of data gathering, but most will come to examples of how we can use this in some useful way to improve how we make decisions. And by doing that, we help, or we complement, or ultimately, or in the end, or in some cases, we might even replace the operator, who otherwise would do all this kind of decision making. And this applies to all kind of operations, from onboard operations to teleoperated or semi-autonomous operations, and might transfer this way to these operations that can actually be done autonomously. It might not be an ultimate goal, but it might be something that we see suitful in the end, in some cases. And if you look at in a more kind of flow chart or some kind of picture, like we have available raw data, and we have two different parts where they can come from. It can come from the machine's own sensor, or it can come from external sensors, which is here collected in kind of remote sensing terminology. That need to be refined in some way, some kind of data processing, so that it's useful. and then it is need to be adapted to some kind of function here collected under the decision support. And then that can lead to having some kind of operation being conducted semi-autonomously or autonomously. And this is nothing new. One really good example of this that has been in use for at least 40 years now, it's when you do the bucking in the harvester, for instance. And that is something that was introduced and possible because the machine had sensors that could collect data on the diameter and the length. You can get the taper, you could do the calculations, connect that to the price list, and then give a support decision to where to cut the tree into a log in the good way. And the benefit of that was, of course, that the human brain is not that capable as a computer to collect and do these calculations that the computer does really, really rapidly. So that is something that is really done. And the remote sensing here, that's the operator. The operator contribute, it doesn't really go into this picture maybe perfectly, but the operator contribute with the remote sensing information about the species, different things that the sensors, the machine sensor cannot fit, or cannot sense. And the semi-automation, the machine can cut autonomously, or the operator can say, yes, this is good, or correct. So this is in place, this has been in place for a long time, and we see similar development in different aspects here. Maybe not that have gone as far or as standardized, but these things are coming into play, and it kind of follows the same pattern, I would say. Then we come to the most common reasons for new technology. We have three main reasons that I come across very often, and the first one is, of course, to cut costs, to do the same thing but do it cheaper. It's often about labor shortage, increase productivity, so we need less labor because it's difficult to get labor or get qualified labor. And the last part is to improve safety. If we can put the person in a safer place when they do the operation, if we can take away the operator altogether when they are working in very dangerous steep terrain, for instance. And in many cases, it's last one on the line here too. It's just cool to have new technology, and we hope that it will bring something better. And that is when we as researchers need to step in and say, well, hey, it is cool, but what does it help? What problem does it solve? How does it get better? Because if you are an inventor, you don't think so much about that. You try to create a need, not too much to find a solution to an actual need. And the challenges, they are huge. If we look upon our context, and I do this comparison in many cases when we talk about robotics, the challenges here are huge compared to many and other industries. And we are in the same magnitude as space, industry, and military. And if you think about the budgets they have, it's a little bit different. They burn money in a totally different league, and we have to be productive. The machines have to pay themselves, and they are very few if you compare to construction machinery, etc., for instance. And we have the worst possible environment, just like military, for instance. It's unstructured, it's outdoors, it's highly variable. We cannot change that. Well, we could, but it would cost also a lot of money to grow trees in greenhouses, for instance. And then we have the demanding work. It's really difficult real-time decisions, and that is what you come across when you start to do these decision supports. How do you know when a tree is in a certain way? How do you take these decisions to do this or that? Which tree should you harvest? Which tree should you let alone? Where should you plant a plant to grow well, etc.? And last but not least, to just kind of top it up, it's huge masses. It's heavy things. If you look upon the industries that are more advanced than us, they handle much smaller things. So machines can be done differently. They don't need to be so endured. And if you look upon what you should do, well, it's pretty basic when you look at it this way. You need to know where you are. If you talk about yourself, if this was a person, this is what you need to do, and the machine need to do and know exactly the same thing, either by itself or by the help of the operator. And it's kind of logic things like, where are your components? Where are you in the world? Where are the different things around you? How should you do the work? What is the plan for it? And you need to be able to move around in the forest because the forest don't come to you. And then you need to actually not just knowing all these things, but you need to be able to do the work itself too. And if you look upon what we have in terms of different research, we have a lot of things happening in precision planning now. There are different names for this, but this is one way to categorize it. And this is kind of just to do the planning in different ways. How are you supposed to do this work? And this is a lot of things happening, and this is not easy, I would say, but it is one of the things that comes first. When you have more data, you are able to start doing the planning differently, and you can plan more detail, etc. So there's a lot of things happening in all different kind of aspects of this, and you will see many examples of this in the conference here. Then you come to actually do something, then it's a little bit more tricky. We will see examples of this too, but the level of research is less, of course. And when it comes to move around in the forest, it's just navigation is one challenging thing, of course. How do you know where to go? Trafficability, how would you be able to go there? Because it's a really challenging environment. It's no roads or so, or not in many cases at least. And then there is, of course, interesting things, the most kind of imagination triggering things about locomotion principles. We have wheels, so we have tracks, but of course you could be climbing, you could be walking, as we will see examples of, or it could be flying, for instance. Are those things that we should explore, and in what way, and so? But that is just also to get around. So then you are there in the forest and you need to do something, actually execute the works. And there are examples tomorrow about things starting to happen that are able to do a little bit of this. So it will happen, but if we look upon the state of the art, what is happening now? Well, the first three things here, I just kind of summarize them in some kind of broad category. It's a lot of things happening there because we are not alone. This applies to basically all different fields of research to do those things. How to execute the work, that is for us alone to solve. It's no other people working so much about that, but that are we doing, and we are coming pretty far away on that, but it's still far behind everything else. But we are building on the things that are done on the upper part there. Move around in the forest. It's also something that many other researchers are interested in because it kind of gives the key to other applications. So that is also a little bit better, I would say. Not so that they have solved things for us to take right on, but it's still happening things. And then we come to the least developed things, because it's also kind of the last step here. And that is to execute the work, to actually be able to do something useful. And this is, of course, in a autonomous or semi-autonomous picture. But if you go to other kind of technology development, is a little bit similar also. So that is what's happening with the current technology. Then we go to what happens with new designs. And when you think about the future and the futuristic things, you often see these kind of designer pictures about this could be happening. But they are in most cases far from being realized. But it's good feed for the thought about what could you actually be having here. And it could be so that you have new locomotion principles. You could be able to manage without the operator. So the operator could be able to manage more tools like several cranes, etc. So all these kind of interesting things that are possible. So this is what you might come to think about first when you hear about new designs. But there is also another brand that is might maybe easier to oversee. And that is that new data enables redesigns that you might not notice so easily, but you might be able to actually make the machines do the same things, but slightly better or even much better. So this is an example from our ongoing work on crane redesigning forwarder cranes or harvester cranes. And this idea is that when we know what the movements are of the crane, we collect data from operators using the crane. We know what movements that we should adapt the crane to be able to do. And then we can redesign the crane. In this case, we have redesigned it to be energy efficient by counterbalancing. You don't see it very easily, but we've done, this is just a very rough and easy sketch. We have a counterbalance here. And the idea is that the crane should be weightless. So the only energy you need is to kind of move, is only to move the crane. Now you use most of the energy to hold the crane, the weight of the crane. And when you start having this kind of information, you can redesign this and you can save, I will not say the numbers, but it's a huge amount of energy actually. considering how much you use the cranes for moving around trees and logs. So this is what can come when they also have this data. So it's a different branch that might be overseen. And the interesting thing here is what comes in the future. We think now that if we can take away the operator, we might have a machine that is without a cabin. We might have 2 bunks, for instance, for a forwarder, and it might be looking really super fantastic. And this is really nice, interesting designs and development. But is it really a mind-blowing development, or is it just the first step that we will forget and that we will have something totally different? If you look upon how the car developed from a carriage, the first cars were carriages without horse. And they probably thought that that was fantastic. That looked great. That is the future. But it's so far away from what they actually developed into. So it's a little bit mind-blowing to think, will it be something similar in the development for us? So it will be really intriguing to see what will the future have for us. What will the machines look like? What will the tools look like? And it will be more autonomous. It will be more digital. But will it be very different? And in that case, how and why will it be different? What is the reasons that we will be doing things differently compared to now? Well, that is what I'm really curious about to see. And this is an old example, but if you want to see something that is a little bit mind-blowing about do things differently, it's from New Zealand and Richard Parker's climbing machine and collaborating machines, how to find some new ways to work. It could be, you can look for logging animations, for instance. It's just a simple idea about how it can work. So with this, I would like to thank you for this opportunity, and I'm sure that we will see very many exciting insights of the possible futures during these days, and I hope you'll have a very good conference here. Thank you.